Hello, my name is Pat Helland, and I'm a software architect from Microsoft Corporation, and I would like to welcome you to Behind the Code. In this show, we examine the life and the works of people creating major software products. Many of our guests are software architects who are responsible for the broad vision of products and for driving those products to completion. Our guest today is Mark Zbikowski, affectionately known as Zibbo. Mark is a longtime Microsoft veteran. He was an architect for DOS, the original operating system for the PC or personal computer. He spent 7 years as a leader of the OS2 effort, working jointly with IBM. He was one of the driving forces behind the Cairo project, striving to advance how applications are built for the PC. He is currently a senior architect and project lead for core components of the Windows NT. Ladies and gentlemen, please welcome my dear friend, Mark Zbikowski. Hey, Mark, thanks for coming. I really want to thank you for coming. Mark, where were you born?
I was born in Detroit.
And did you grow up there?
I grew up in the burbs outside of Detroit, a little city called Bloomfield Township.
Okay. And what did your mother do?
She was a stay-at-home mom.
And what did your father do?
He was a radiologist.
So, now I understood you went to a private school in Detroit, Royport City and Country. Wasn't it there that you discovered computers?
Yes. In 7th grade, the University of Detroit made available a computer teletype for all of the students at school. I very quickly monopolized it to the point where I actually took the teletype home for the summer.
I can imagine that. I actually can imagine that. So what fascinated you about computers?
The fact that you could envision things in your head and write programs to actually do them. Initially, the sorts of things I was doing were programs to find primes, to draw little stars on the teletype.
Now, didn't you also have a passion for math? And didn't that lead you to meeting a new friend at age 14?
Oh, yes. The school I went to offered us an accelerated math program and the opportunity to compete in some statewide math competitions. I guess when I was in 8th grade, I took the Michigan math competition and ended up finishing in the top 1,000 high school students in the state. As a result, the National Science Foundation offered a program for promising math students at Oakland University in Michigan. And at that point I met Steve Ballmer at math camp.
And he was 14 also?
Yeah, he was 14. He's 3 days younger than I am, but he was a year ahead of me in school.
Okay. And so did you compete with him in a friendly fashion?
Well, that summer we met because my mother was trying to arrange rides to Oakland University, which was a good 30 miles north of where we lived. Steve and I were good friends. We didn't compete so much math for the first couple of years. We were just good friends. We'd play basketball at each other's house, go swimming together. We went to rival high schools together. And long about my sophomore years when I started doing better in math and he started doing better at math, and there was a good rivalry between us.
That's cool.
Yeah.
Now, in 1974, you graduated from high school. Now, you didn't really apply to Harvard at first. How did you get in there?
Steve Ballmer, just before my senior year, he was a year ahead of me in school. He had gone to Harvard already. The way Harvard recruits people, at least in the Detroit area, is they use students to go and find promising up-and-coming talent. Steve had talked to the local Harvard representative for the Detroit area and told him that I was a good guy. And Steve called me up and said, "Hi, Mark, why don't you go and talk to this fellow?"
And so it was really through Steve's influence that you ended up at Harvard.
Yes.
Yep. Now, didn't you end up in a class with Bill Gates? Did that time seem to fly through?
Oh, yes. Bill is notoriously not a morning person. It was my freshman year, I think, that we were taking a 9 o'clock class in number theory, and Bill would sit in the back, and the class did take a lot less time because every so often Bill would reach up, move the clock forward a little bit, go back to watching it, then reach up and move it forward.
So you graduated from Harvard in 1978 with a degree in advanced mathematics. Then you went to Yale and you had studied for a master's program in computer science in artificial intelligence, or the attempt to actually make machines emulate human thinking. Now, when you graduated from Yale, I understand there was actually a spelling error in your diploma. Can you tell me about that?
I received my master's degree in the mail. Thank you, Yale. Long about March or so of I guess that was 1980. I looked at the diploma, which was all in Latin. It's the first diploma I'd seen in Latin, and was reading through it. And it was a pretty clear typo, but they misspelled Republica. They spelled it Republica. Yeah, yeah. So I took that to the diploma office and claimed that there was a misspelling on my diploma. They looked at my name and they said, "No, your name is spelled right." I said, "That's not the issue," and showed it to the person, and her jaw dropped, and they had to recall 2,000 or 3,000 diplomas that had this misspelling on it.
Yeah. That is great.
Yeah.
And so after you got your master's, you went to Digital Equipment Corporation, or DEC. I know that I dreamt of working at DEC, as most of the computer science students of our age did. What did you work on when you got there?
I was in a performance analysis group. It was actually attached to a marketing group, and our job was to run benchmarks on operating systems and hardware from both DEC and from competitors to try to find out what the price-performance ratios were.
Mm-hmm. And I understand the phone rang one day, and there was a phone call that then changed your career moving forward.
Yes, I was in my apartment, and one night I was making dinner, and the phone rang, and it was Steve Ballmer. And at that point, he calls me up and says, "Hi, Mark, do you remember me?" And he's kind of a person you don't forget.
Yeah, I can imagine that.
He told me about this company that he had started in Seattle, or that he was working at in Seattle, something called Microsoft, and he asked me if I remembered Bill Gates, and I didn't. And, he said, "Do you want to come out to Seattle? We think you're an interesting guy. You might want to work here." And I told him that I was within crawling distance of the best bars in Boston, that this is my first job after college, and I'd like to stay at one place for at least a little while. And he thanked me and told me if I ever wanted to do a free trip to Seattle, call him. So I hung up the phone and thought, he was right about me going to Harvard, being the right place for me. I picked it up, called him, and said, "Fly me out."
And so what was it about Microsoft that made you leave this incredibly cool company, Digital Equipment Corporation, to go to work for this tiny little place?
I had a very interesting set of interviews. I flew in on a Friday, and I was interviewed by Bill probably 4 or 5 times over the course of the next 2 or 3 days. I was impressed by his energy. I was impressed by his vision for the power of these small computers. I was still interested in what the small computers could do. It was it's a real challenge to get them to do anything more than just blink lights.
Mm-hmm. Mm-hmm. In 1981, you actually started at Microsoft. What were you hired to do?
I was originally hired to rewrite the basic interpreter that Microsoft had from assembly language, which is what we had been using, into the language C.
Mm-hmm. And so what did you actually do?
This was a joke that no one ever works at Microsoft on what they were hired to do. It's probably true today.
Yeah, there's a lot of truth to that today still.
I ended up initially was asked to port a linker that we had purchased from Convergent Technologies over to the IBM PC.
Mm-hmm. And so who was your first boss?
My first boss was Bill Gates.
So Mark, can you tell me about how Bill handed out bonuses?
My first review with Bill was in June, I think, of '81. I was called into his office. We sat down, spent about an hour talking about what worked and what didn't work, what his expectations were of me for the next period of time. And at the end, he said, reached into his pocket, pulled out a bonus check. Very instant feedback.
Yeah, I can't imagine that. That seems good.
God help me if I wasn't going to get a bonus check.
Yeah, I don't know what he would have found.
Pink slip.
So can you tell me the story about your initials being in computer dictionaries nowadays?
The original IBM PC had a means for executing programs that relied on taking an image of the program as it was running and actually storing that in a data file on disk.
That's called the loader.
Well, that's the process of loading. The format that they had at the time was not powerful enough to handle what was then going to be more and more obvious, which was programs that were larger than 64 kilobytes in size. Mm-hmm. So we had to find some way to distinguish those files, which are larger, which may have more rich information, from the old, what are called COM-style files. Mm-hmm. So we needed to put a little header at the front, describe what the format of the rest of the file was, and
it had to be different. It had to be different.
Had to be different. So the first 2 bytes, which normally were instructions in the COM file case, I said, let's use my initials, since they don't make any sense as actually executable instructions.
Right. So today, every Windows program begins with the letters MZ.
Yeah.
Yeah, that's pretty cool. So back in 1981, the personal computer was so tiny compared to what we have today, and also what you'd been working on at Digital, right? It had 32 kilobytes and less than 5 megahertz, and it was just tiny little machines at the time. Wasn't that a huge change for you? Wasn't that difficult to deal with as you came into Microsoft?
Yeah, it was a completely new environment. The size of the memory that we were given was it really taxed your ability to think and to write code. At those days, you really had to think hard about what features you wanted to put in because there wasn't enough room in memory for your features and a user program.
Yeah, and so everything was oriented around how to squeeze and how to get all the stuff into these tiny little machines.
Yes.
So what was the vision for DOS? And what were the technology challenges associated to that vision?
The vision for DOS initially was to make it very easy for programs that were written for CP/M, which was at the time the most popular operating system. Make it easy for developers to translate those programs from the smaller machines to what was the PC, which in theory was going to be a larger machine, and make it very easy for those developers to move their programs.
So what about that made you passionate? What was exciting to that process?
There were two parts for me in there. The first part was the ability to move programs very easily and the sheer challenge of doing a lot in a very small amount of code.
So you were a major point person in the relationship to IBM for DOS, and you made many trips to Boca Raton, Florida to deal with their PC headquarters. Now, Microsoft is a little tiny company with, a very different corporate culture than what IBM had as this big, staid, process-oriented company. Can you tell me about what it was like working with IBM?
They were a very demanding customer. Up until the point where I began work at Microsoft, I was never in a vendor-vendee relationship. But here with IBM, we were a vendee. We were providing them with effectively contract software. They were extraordinarily demanding about deliveries, bug quality, features, etc. It was the big challenge there was we had a vision which was far beyond what their vision was.
And so how did you sort that out, working with a little company to the big company? How did you sort that conflict of vision out?
We checked a lot of code in.
So you just kind of went and did a lot of it.
We wrote, I guess in '82, we wrote a list of all the features we wanted to put in and gave it to IBM, and they more or less said yes. And that was sort of the nose of the camel getting into the tent.
And so you just put all this stuff in.
Yeah, absolutely.
So this was your first time doing cross-company work. What was your big takeaway of the challenges of working across corporate boundaries?
Oh. The hardest part about working cross-company is to be incredibly precise about deliverables, and also to make sure that the customer doesn't keep changing his mind about what the deliverables are.
Yes, I can imagine that. That's very challenging. So your colleague, Jerry Dinetz, noted that your constructive relationship with IBM and work on DOS was critical background that led to the possibility of joint development and of what became OS/2. What did Microsoft learn? What were your challenges? How did this change Microsoft for the better, having to work with this large company?
It forced us to become a lot more disciplined in how we did development. Up until that point, we were a bunch of college kids who were just writing code and testing it on our own, and largely without a lot of structure. Working with IBM, they had an incredible amount of history and experience with large software projects. There was a learning experience for all of us to bring the good features of the large company into the small Microsoft.
And that really helped shape and form Microsoft moving forward.
Yes.
Yep, I can see that. You spent about 4 years working on DOS from 1981 to 1984. What do you think was your most significant accomplishment during that period of time?
The part that I'm most proud of during the DOS time was going between DOS 1.1 and DOS 2.0. That's where we put in support for hard disks, large hard disks, a whopping 10 megabyte hard disk. We put that support in. We put in hierarchical file system, because at the time we only had files in the root folder.
Yep.
We now had the concept of being able to put in nested folders contained in folders, which greatly simplified how people could organize data.
Oh, it was a huge step forward.
Right, and we only did that in 24K of code.
That's quite an accomplishment. That is quite an accomplishment. So the mid-1980s was a fascinating time for Microsoft. You were working on multitasking, or the ability to run more than one application at a time on a PC. People were getting very excited about the graphical user interface. And there was a joint development agreement that was made with IBM to do OS/2. All this amazing technology was taking place, and yet there were challenges with incompatibility with Windows. What was your vision for OS/2?
The vision for OS/2 was to bring many of what were standard mainframe technologies, things like multitasking and it's called protected address space, to allow programs to operate and not interfere with each other. Windows at the time, Windows 1 and Windows 2, applications could interfere with each other. Quite often you'd have to reboot your machine, power cycle your machine. With OS/2, we wanted to break that. We wanted to have applications in separate areas, in separate rooms, so that they couldn't interfere with each other. Unfortunately, many applications that were written for Windows required some degree of sharing.
Right.
And so by breaking this, we were actually breaking existing applications.
And so what were the consequences of the fact that you broke those existing applications? Even though OS/2 in so many ways had better technology, it broke the existing applications. What did that do? What happened?
It made the customer's investment in software nearly worthless if they were going to be moving to OS/2, because they'd have to reinvest in new software. So from a customer standpoint, this was really not the right solution.
Yep. And so that kind of put pressure on OS/2 that was very difficult.
Yes.
Yep. So one of the major innovations you did during this period of time was the installable file system, and that laid the foundation for being able to add devices, cameras and scanners, and extending the PC in areas that really weren't thought of at first. I understand IBM was not terribly supportive of your idea, and can you tell me about that?
We had proposed in OS/2 1.1 the idea of putting in an installable file system. They didn't think it was. They thought it was not that interesting. Under the covers, they had been writing their own file system. When we'd shipped OS/2 1.1, which was the first version that had a graphical interface with what was called the presentation manager, at that point, we were able to convince IBM that this was the right thing to do.
So there was all this pushback. What made you keep going to try to push installable file systems into OS/2 and to make it happen?
The vision was that what we had at the time, the FAT file system, was going to run out of steam. It was not going to be capable of handling larger disks. What we have today in disks in terms of gigabytes, billions of bytes of data. We needed to provide a way to be able to hook in other file systems, other ways of storing and accessing information. One in particular, one very significant one, is the ability to be able to address information on another person's machine, a network file system.
So from 1988 to 1990, OS/2 shipped 3 different versions. Yet the project didn't materialize as it was hoped. Can you tell me why?
There was the basic incompatibility between Windows applications and the OS/2 presentation manager model of computing. That was a large roadblock. It was a big barrier to applications being moved from the Windows platform into the OS/2 environment. The biggest problem that I found was that IBM was using OS/2 as a platform to sell their hardware. And it was very difficult for them to understand that we needed to put features into the operating system to aid in compatibility, as opposed to putting new features in, the same effort, but being directed for supporting a new piece of hardware that they wanted to sell. So this is a very interesting conflict between Microsoft and IBM, where we wanted to sell software that could do new and wonderful things, and IBM who wanted to sell their hardware.
I see. So given that OS/2 was discontinued from Microsoft's perspective anyway, what did you take away from that experience?
This was, again, about understanding the customer that we were trying to sell to, as opposed to the technology we were trying to create. There's a tremendous tension there. You want to solve the customer's problems. You want to do that in a way that maximizes their value, which is not only just the problems that we're solving, but previous investments they have in hardware or software. But at the same time, we want to be able to add new features that allow future applications to be able to solve further problems that customers may have.
So after 7 years of work on OS/2, with lots of technical contribution, lots of cross-team, cross-company contribution, what accomplishment are you most proud of from that period, and why?
I think the conception and delivery of the installable file system portion, that is a whiz-bang piece of technology which people largely take for granted now. But at the time, an operating system would be delivered with a file system very much married together. And you could not provide an extra one or a different one without reconstructing your entire operating system, which is not something that that customers do.
So in 1991, you spent a little less than a year working for Paul Maritz as a technical consultant and an advisor on technology issues. Now, Paul Maritz was group vice president, and he basically owned all of product development for Microsoft. How did you feel about this role? What was it like being an advisor?
It was a very interesting challenge. At this point, I had been a technical leader and an architect doing the work on the products and not really participated in any of the business and long-term strategy decisions. I found this a great opportunity to learn a lot about other technologies, as well as to learn about the issues in the strategic business realm that Paul was having to face.
So working for Paul, you had the opportunity to see across all of Microsoft's business, to look at many different projects that were going on inside. How did that change your perspective of the company?
It didn't really change my perspective of the company. It changed my perspective of how I needed to do my job to succeed. I spent a lot of time looking at the strategic parts of Microsoft, where the other vice presidents and other leaders thought the company was going in terms of future products, future hardware.
So what did you take away from that, and how does that impact you moving forward in your job?
You cannot be just a software person and succeed at a higher level. You need to understand the products, not only from the narrow marketplace that they're going into, but what the long-term strategy for your company, to understand what markets you want to move into, how you want your products to work together.
Really folding much more of the business focus in rather than simply the technology focus.
Correct.
In late 1991, you started working on Cairo. This was a great challenge to try to figure out the future of computing and what was going to come next. What was Cairo?
Cairo originally was a collection of object-oriented technologies that we were trying to add to the core Windows NT platform that would provide a way for applications to much easier share data, for the applications to be constructed in a much simpler fashion, for them to be able to naturally handle access to information locally as well as remotely, as well as be able to run on your machine as well as run on your machine, if we were connected together, run on your machine, be able to access data, and for our applications to actually exchange information.
So this would really change the way applications were built and how they would work together and how they would be integrated together.
Yes.
So why was working on Cairo such a great opportunity for you?
Cairo was an opportunity because I was able to participate in the architecture and design of the product very, very broadly right from the start. From being able to store information, to find information on a network, to be able to change how programs were going to deal with the information, how the programs were going to change in their structure. I was able to do this from the architecture level, as well as a development leader, as well as an individual contributor.
So part of Cairo's vision, was from Office. It came from Office, the compound documents, allowing you to have Word in which you would embed a PowerPoint picture, for example. What role did you have in the creation of compound documents and how they were integrated into Cairo?
The compound documents were created by, the concept came from the Olay group. That was with Tony Williams and Bob Atkinson. They had looked at the model for how applications were going to visually embed information, and they were translating that into embedding that structurally in the data storage. This required, however, there to be a layer that ran as part of the application that would take what appeared to the operating system as a large single block of data and be able to pull the little pieces out and segregate them so that the word processor and the spreadsheet portions of this document, for example, if you had a spreadsheet table embedded in your word processor, in your Word document, so that the information there was actually separate as far as those two applications were concerned. They didn't understand each other. For Cairo, we wanted to take this, instead of having this layer, which is part of the application, we wanted to put that layer and put that into the operating system itself, giving this benefit to everybody, plus also being able to have a much finer-grained access and much higher performance access to that data.
And so as they were defining the way these pieces would put together, you were trying to make that thing that would put pieces together and push that deeper into the Cairo operating system, the operating system with Cairo.
Right.
What pressures arose as you were trying to keep the Cairo aligned with this work that was going on in Office?
The biggest pressures at the time were that there was very slow adoption of OLE and the COM programming model, the way the applications could share information. There's very slow adoption within Microsoft of some of these technologies. Cairo was being pushed as what applications should be writing towards, yet there was still the problem that Microsoft applications were not moving fast enough to the programming model.
And so trying to keep that in alignment was a real tough one.
Well, at the same time, the Compound Document Group, the OLE group, was changing their ideas, and we were having to follow them. But since we were trying to do things in a much more efficient, much higher performance fashion, every change that they would make required us to revise our thinking entirely.
That must have been quite a challenge for you.
Yes.
Yes, I can believe that was quite a challenge. So around this time, the folks from Windows NT had built the NTFS, the NT file system. How did the relationship with NTFS impact Cairo's OFS, or the object file system, which you were working on?
NTFS had several features to it that distinguished it from OFS. It had security built in, the ability to protect information against unauthorized access. It was also what's called a journaled file system. It allows you to run your system, and if you lost power, the file system would retain its integrity. There wouldn't be any corruption. Okay. Initially, in the OFS days, the object file system from Cairo, we had thought that we wouldn't do that, but it took us a very short period of time before we decided that really was the right way to go. NTFS, however, was very much oriented around the traditional model of programming, where you view a file as just a large block of information. With the object file system, we wanted to allow applications to break that information out. So there was a fundamental tension there between those two.
And so how did you work those tensions between NTFS and Cairo's OFS team?
The tensions were that the NTFS group was going to largely ignore the Cairo group because we were not anywhere close to shipping, and which is very true, and the NT group was actually shipping a product.
Right. I understand.
And so they looked at us, they put all their resources into testing, into the performance aspect of NT and NTFS, and we did not have any of those resources for the Cairo side of things.
I understand. So what happened to make you think that OFS might start to be at risk? What was occurring?
There were some technical changes that had occurred, as well as some organizational changes that were very apparent. We had originally planned for OFS to be adequate for storing mail messages. But mail messages had changed in their typical size. They went from being merely a few words to being paragraphs with different fonts and pictures embedded. So those places where we had optimized OFS, they were no longer appropriate for mail messages of that size. From the business standpoint, it was clear that the NT group was spending all their performance and testing resources on their premier file system, NTFS, and those resources were being taken away from OFS.
So how did compatibility with NTFS impact this?
It was clear that people in information technology shops in large companies, places where there's their company data, they didn't like the idea of having to run a new piece of code on their existing data that would change the way the data was stored. This is the company's primary asset. If there was a mistake in this new piece of code and they lost their primary asset, it's not a very good business situation for them.
So by 1995, you've been leading the effort to build OFS for about 5 years. You had a team of 10 developers, and you personally made the decision to cancel it. Can you tell me about that choice?
It was a very tough choice. We'd put 15 man-years worth of effort into it at least.
Yeah.
We had kept it alive. It was actually functioning very, very well at the time, but the needs of the product and the needs of the product, not the project, but the product, as I said before, this information technology shops, IT shops, could not tolerate having two premier file systems. This is the user's data. They don't want to have to change how the data is stored on a disk. They don't want to use a new piece of software to deal with the company's assets. So even though we have a new functionality and new features and faster in some ways, there was enough of a roadblock here that people were not going to adopt it in the timeliness or the volume that we had hoped. And from a long-term view, it was probably the wrong thing to invest so much effort in OFS. I remember walking into Lou Perizzoli's office and telling him that we just ought to kill it, that it's the right thing.
Yeah, but you'd invested so much in that. I mean, I can't imagine the difficulty in realizing that the business decision required giving up all of that you'd poured into it. I mean, tell me about talking to your colleagues and what that was like.
It was a very tough decision. It's one of these things where you have a bunch of friends that you work hard, play hard together,
yeah.
And to tell them that what we've been working on the last 5 years, we're just not going to do anymore. It hurt. It was very hard for me to say it. It was there was a lot of disappointment from people. I felt that I let them down by having led them all this time, and then only to be the person at the end to pull the plug.
But it really was your responsibility to look out for the business and to make the right decision for the business. And so, even though it hurt, and even though you felt like you'd let them down, you had no choice, right?
Correct.
Yes. So, how has that made you a better architect? How has that process helped?
I spend a lot of time thinking about what we're doing now, what the future is. I have learned more about how companies adapt to new technology. I've learned more about how application groups, outside of Microsoft, adapt to new technology. Being able to reconcile those with my own knowledge and my own goal of adding more capabilities and solving more of customers' problems, it's a very difficult trade-off you have to make. And you also have to keep much more in your forefront the degree to which people will adapt to new things that you give them.
How does it make you feel about taking risk? I mean, you poured so much into that, and then it hurt so much to let it go. I mean, is this something that impacts you today?
Yes. There were actually two big losses that I had. The first loss was actually the end of OS2.
Of course.
Yeah, I spent
7 years.
With a tremendous group of people working on OS2. I was with Moritz at the time that the big decision between Paul, Steve, and Bill made about divorcing IBM. I saw that. I was in on many of the meetings as part of those discussions. I saw it coming, and it made it very difficult for me to come to work during the OS2 days, knowing that there wasn't going to be no feature for this part of the product, yet working with people that I knew were still working on it and had their hearts into it.
Right.
And that was the trust of people that I work with and work for is something that I don't want to ever sacrifice. I understood the needs of it, the business needs at the time, but it still is something that hurts very much. OFS was a loss as well. It was literally the end of what was Cairo at the time. Cairo was originally a collection of technologies that were put together and viewed as a separate product, but then were pulled off one by one and integrated. From the standpoint of how it affects me today, I'm a lot less, I'm much more risk averse, I should say, than I was then. I understand that that you do have to take risks, but I'm willing to take much smaller risks now and much smaller steps that I know I can succeed in than much more giant steps where there is a significant chance of failure. I'd rather take more incremental steps towards an ultimate vision, but not the first big leap.
So much of your work that you'd poured your heart and soul into, it had come out in a different form. It had come out in different products. And it was very hard for people to look back and see the origin of the innovation. What was that like for you?
Yeah. Windows 2000 was the product that came out in the year 2000 that had all the various components of the original Cairo. At the Windows 2000 ship party, there were a number of us who were wearing our Cairo shirts, saying we finally shipped Cairo. A few years late. It wasn't the same vision that we had, but to my mind, it was the same. It was the same vision because we were able to have what's called a directory service. We did have a distributed programming model. We did have a file system and a content indexing system that allowed you to search for files on your disk and across the network. It had a shell that was extensible, that was incredibly friendly for people. All these components were part of Cairo. And they came out in Windows 2000. So the effort that we had put into Cairo as a product, the angst we had felt, the sheer psychological capital we had spent on this, it was unfortunate that Cairo ended the way it did, but yet all of our hard work and technology and ideas did make it out. So that was, for me, that was the benefit of Windows 2000, the joy of seeing all this work that we had done ship.
In 1996, you began working on the NT team. What did you work on?
After we had shut down the OFS part of Cairo, I worked for Lou Perazzoli. I was an individual contributor. At the time, Lou had perhaps 7 or 8 people working for him that he called his unmanageable people. We took very little direction from Lou. We took very little direction from anybody, and we did what we thought was right as far as the entire core part of the Windows operating system.
So what were your goals of what you were trying to accomplish?
The part that I was most involved with was trying to make the system smaller and faster. At the time, hardware was more expensive than it was now. Memory was more expensive. The machines were much slower.
But software was getting bigger.
Software was getting bigger very, very fast.
Yep.
The applications, when they would be ported from Windows to Windows NT, would grow in size because going from a 16-bit operating system to what's called a 32-bit, all your information roughly doubles in size as part of your program. The goal of the operating system is to do lots of useful things for the programs, but leave as much memory left over for the application as possible. Okay. So that's what I spent my time doing, finding ways to make it smaller and faster.
So when did you start to lead a team?
Probably in 97, 98, I think. At the time, the file system team that was part of the NT base group working for Lou Perazzoli was probably 4 people or 5 people. They were very good, very sharp people. The fellow who was leading the group really was not interested in being a leader of a large group, and he was actually starting to be a little burned out from leading just even the team there, which is fine. At the time, I knew NT file system. I'd done some work on making NT file system faster, and at that time, when I heard that this fellow was thinking about doing something different, I went to Lou Perazzoli and said, I know how to do this. Give me the opportunity.
So you've worked very hard through the years to protect Microsoft's intellectual property. Getting patents is a big thing for you, and you work on getting patents for your ideas and helping people to get patents for their ideas. Can you tell me about being the patent czar, which is the title you have? One of your...
That's actually a lot of fun. It's both a lot of fun and it can be very, very annoying.
Oh, really?
Yes. The fun part is being able to listen to ideas and help people take ideas that they have that will be very good ideas if, when we implement them to help help Microsoft products move forward, but also protect Microsoft from people who are trying to steal our technology and et cetera.
So of your 16 patents, which one is your favorite?
This is this related to the installable file system work that we had done in OS/2.
And what was the name of the patent?
Well, as originally filed, it was an installable file system. However, as part of the process of filing patents, typos occasionally occur, and the patent as finally granted by the U.S. Patent Office was talked about an installable fire system.
So you currently hold the patent for the installable fire system.
That's right. In an operating system, I do. Yes.
Yep. A huge chunk of what you have to do is look and put yourself into the minds of the person you're trying to work with. Before it was different technology ideas. Here it's the business people and how the technology can be used to help with the business.
Actually, that's been something I've discovered in a lot of my interactions with other people, which is in talking with somebody and doing a technical discussion, I try to put myself in their shoes and try to understand their viewpoint on something. Not necessarily argue my own parochial, narrow viewpoint, but to put myself in their shoes and try to understand how they're thinking about the problem.
And then that allows you to form something that solves both needs.
Correct.
And come up with a completion for that.
Correct.
So you're well known as someone that both junior and senior people want to work for. Can you tell me about your style and how you work with others, and what do you strive to do as you work with others?
I strive to let people be themselves and try to allow them to grow as much as they're capable of growing. I'm known as a fairly hands-off manager. I prefer not to day-to-day tweak people, although there are times when I need to do that. I prefer to allow people the freedom to do their job. I work around them. I talk to the people who they work with. I watch how they check code in, how they develop code. I watch some communications they have, and I will tweak them along the way, give them, shape their direction, shape their thought, rather than going and with a heavy hand saying, "Thou shalt do something else."
Yep. So everyone who we talk to, notes your upbeat and positive personality, and you're always looking at things, with the glass half full rather than the glass half empty. And we've literally had people who've worked with you for years and years who've said that they've never seen you get angry. How do you do this, and why is this so important?
Well, I close my door when I get angry. Life is too short to stay mad. Also, just keep your eye on the bouncing ball. You have to work with people. You can't have bad feelings. You can't. That interferes with what the bouncing ball is doing. I'm here at Microsoft because I want to ship products that solve people's problems. Millions of copies of it, but I still want to see people do that. I still want to be part of that process. This is even though we work entirely in our heads doing software development, doing architecture, fundamentally what we do is a social activity. We do interact with people every day. You talk to people. You have to be able to work with people. You have to be able to work well with people if you're going to achieve any sorts of organizational goals.
Now you have lots of responsibility at work. How do you make time for kids? How do you focus and shift your focus between all that responsibility at work and the joy of being with your kids?
I think focus is important. It's part of keeping your eye on the bouncing ball. For me, the focus that I have, when I'm at work, I'm very much dedicated to getting the work that I've set aside for myself that day completed. And I try to, in my 9 hours or 8 hours or 10 hours at work, I have an idea what I want to get accomplished every day. And I work really hard at doing that. Clearly, things like reading email is something I can't predict, and my only goal for reading email is to try to stay somewhat up to date on it. But come the time that I leave work, my focus is not on work anymore, even though it's always in the back of my mind, but on my family. So I would leave work, at 6 o'clock, get home, have dinner with the kids, play with the kids, put them to sleep, be with my wife, and when she would retire, then I would sometimes, spend another 2 or 3 hours doing email, reading documents, etc.
So, out of the NT era and all the time you've worked on NT, what accomplishment are you most proud of?
Wow, I think there's the narrow individual contributor part. I worked on the original compression algorithms and compression code, being able to take large blocks of information and shrink them down by removing redundancies in such a fashion that I can recognize where the redundancies were and put them back. Be able to store the information on disk smaller than what the application was trying to do. I was able to do that in a frightfully small amount of assembly code, reflecting my DOS days, and did it in such a fashion that it was about as optimal as you can get it.
So Mark, you've been at Microsoft for almost 24 years. What do you love about being here? Why do you stay?
This was asked of me on my 15th anniversary at Microsoft, why I'm still here. I work with really smart people. I work with a great set of people, not just nearly in my group, but in my organization and across the company. The energy and intelligence and just sheer excitement that these people have is infectious, and I love that environment. The work to me is always interesting. Okay, keeping my eye on the bouncing ball. Some days when you're doing debugging or you're going through the last bit of stress testing, it's boring. But the work is always interesting. I don't know what I'm going to be doing in 6 months, but I know I'm going to be just totally wrapped around it. I get to see millions of people use what I make. That's 3 things that are just tremendous. I hope that other people at Microsoft have those vision too.
That's cool.
Yeah.
So we were fortunate enough to get a chance to sit down and talk to Steve Ballmer about you. And here's a little bit about what he has to say.
People at Microsoft can learn a lot by understanding the kind of work and success Mark's had. Mark is a technical guy. This is a company where that's important. We build software for our business. That's what it is. And guys who can lead technical projects, be thought leaders, whether they want to be big managers or not big managers. Architects are folks who lead by force of their thoughts, not necessarily their management, all of their management prerogative. Mark's done that. Mark's a guy who's been at this now for almost 24 years. Mark's been here, and that's incredible. I'm sure I recruited Mark about 24 years ago. This month, October 2004, because I'm pretty sure that I recruited him the end of 1980, and he's worked at a high pace, a consistent pace, but with good work-life balance for all that period of time. Mark's a guy who's had a lot of good fortune in life, like many of the early Microsofties, but Mark's still here, making the right kind of contribution with the same kind of energy and passion and brilliance and dedication. And what more could you want for out of a leader of this company?
Wow.
You deserve it.
Oh, thank you. Wow.
So we're here with a group of our Microsoft colleagues who help write and create the software that we love. In a moment, we're going to let them ask questions of Mark. But first, I'd like to start with a few questions that we ask of all of our guests. Mark, how would you describe what you work on to someone who is not technical?
If someone is familiar with using a word processor on Windows, when you're typing away and you want to save your document so you don't lose it, you type file save, and the little arrow turns from an arrow to an hourglass and then back. While it's the hourglass, that's my code.
So can you finish this sentence for me? You know you're a computer nerd when?
You know you're a computer nerd when you have planned a meeting with a person that you're very much interested in, and you work all week and you just can hardly wait for the weekend, and you realize on Friday afternoon, you look at your watch and it's not Friday afternoon, it's Saturday morning. And you are really panicked about having missed this, but then you realize you'd set your TiVo.
Other than computers, what are you passionate about?
Children.
What else in life would you liken to producing software?
The metaphor of an architect, a combination of an architect and site manager and master carpenter and framer and finish carpenter in a building site. My job spans all those.
Mm-hmm. So what advice would you give to people in your field?
Understand what your company's goal is. Keep your eye on the bouncing ball. Day to day, your job might not be fun. It's mostly fun for me, but day to day it's not fun. But keep your eye on the ball of actually trying to produce something that people will use and will make their lives easier.
Mm-hmm. So we know that there's an idea we call a data structure, which helps you to organize your information and sometimes connect it together. I'd like to know what your favorite data structure is and if you would be willing to draw it for us.
Okay. Okay. Data structure looks like that. You'll see it. It's got some fields. There's going to be what do we call a checksum here. There's a big pile of data down here at the end.
Would you be willing to show the audience?
Okay. This is the exe file header. It starts with something that's recognizable and then goes downhill from there.
Thank you, Mark. So now we would love to have some questions from the audience. Who would like to ask the first question?
Hi, I'm Rajiv, and my question is, why has integrated storage been so difficult to do at Microsoft?
Integrated storage is the idea where the operating system and all the various parts of code that come with the operating system understands how information is laid out actually stored in files. So this means taking things like a Word document and exposing to other programs the structure of a paragraph or the properties of a character. It's been difficult at Microsoft, primarily because that is a vision that is both all-encompassing, requires changing a significant amount of code and a significant of existing running programs, and at the same time while maintaining as much compatibility as possible. It's a huge scope. Turns out, we always bite off far more than we can chew. We always want to go to that big ultimate end goal rather than taking the small steps. Caro was one big goal. I can name several other projects that were also very long, big goals. That big goal, we believe right now we understand what that goal is, but as we achieve it, as we start working our way towards it, we realize that there's a whole lot more to that goal than just what we thought. So we aspire to something very, very big, but you realize that to get there, you have to really move mountains.
Hi, I'm Ted. Mark.
Hey, Ted.
I'd like to know who plays the role for you that you have played and continue to play for many of us. The role of the mentor, the guru, if you will.
Wow. I've had a number of people that I've drawn lessons from over my time at Microsoft. Clearly, Steve Ballmer is a significant part of my life. I mean, I wouldn't be here without him. He and I don't see each other on a weekly basis. We are still great friends. I watch him and how he is the public persona of Microsoft. I also watch him internally. He is a tremendous role model, at least for me. That's from the standpoint of the business. From the standpoint of technology, there were several people that I learned a lot from. The two most notable ones were Gordon Letwin and Dave Cutler. Gordon was a phenomenal assembly language programmer and taught me a lot about assembly language programming and how to structure certain areas of thought around operating systems. Dave Cutler is the master of engineering. He's a master of here's how you work in a big group, here's how you develop your code so that people can use it, here's how you put together a product that is reliable, robust, solid.
Hi, I'm Krish. Aristotle classifies complexity into two. There's essential complexity, which is in the problem, and accidental complexity, which is in the solution. And much of software industry is notorious to create these accidental complexities. Over the years, in your experience, do you think we have gone a long way in conquering this complexity, that we don't create complex solutions for simple problems or even complex solutions for complex problems? And can you share some insights or anecdotes? Are we on the right track in terms of providing simple solutions?
I think that as a whole, the industry has failed miserably in terms of controlling accidental complexity. Essential complexity, it's there. It's part of the problem. You can design products that address the essential complexity that are not a lot more than that. However, if you don't think about your end solution well enough and draw boundaries around it, okay, and understand that your goal is to truly minimize the accidental complexity and have that as one of the forefronts of your thought, okay, you're going to have accidental complexity and it will grow just out of bounds. The Windows Group is actually doing something very important right now with their architecture review board. They're forcing people to write down at a high level their component and its interactions. This is teasing out a fair amount of the accidental complexity and really drawing boundaries around pieces of new technology. The accidental complexity is going to be with us forever.
What do you look for when you hire someone new?
The people who work for me are almost invariably incredibly self-motivated. Even people coming out of college, I try to find people who are driven, who aren't the sort of person who is narrowly concerned with their piece of the code or needs to be handheld or coddled. It's a hard thing to do, and yeah, I'm a little particular about the people who I want working for me. I've been very fortunate in finding them.
When I came to Microsoft as a software architect, people were at pains to tell me the definition of a software architect. They would say, program managers are responsibility without authority. and architects are program managers without responsibility. And it's an interesting role because it has an enormous amount of ambiguity in what its actual deliverables are. You're not a developer. Your job is not to write a lot of code and own that code. You're not a program manager. You're not to be writing specifications. And how do you understand the role of the software architect? How do you conceptualize it? And if you're mentoring software architects, what do you tell them to do?
Well, I've been fortunate that in my career here that I've never been just a pure software architect. I've always been a combination of architect and individual contributor, or architect and development manager. So I've been able to occupy my spare cycles with that. A pure architect is, as you've described, is a very funny position. You need to, an architect at Microsoft needs to be incredibly knowledgeable about actually, many aspects. I don't believe that software architects don't write specs. I think that software architects ought to certainly author specs. They ought to be the prime reviewer and the prime critiquer of other people's specs, not just program management specs, but also development specs, designs, etc. They clearly, the word architect implies, is in the building environment. You have to understand all aspects, the human aspect of it, the physical construction aspect. You have to understand everything about the product, okay, from what the uses are in terms of the program management side of everything, all the way down to how it's constructed, which is the developer side. You have to be, in a sense, an expert on all of those.
Hi, my name is Chris. What was the largest technical challenge in working on your various products that you've had to overcome? What did you have to do technically, but also what did you have to give personally to that challenge?
There have been so many challenges. Narrowly, the thing that I'm probably the most proud of in all my time here was actually in the individual contributor realm in terms of writing code. I can think of pretty much the three things that I'm, in terms of, part of what I'm actually known for is writing small, fast code. DOS 2, we put a hierarchical file system and program loader and installable device drivers into 24K. And that was, I think we worked really, really hard at that. Lost no small amount of sleep. I flew to Florida a lot. Then my two big efforts in terms of compression, disk compression. I wrote the assembly version of the double space compression, and subject to patent issues. It wasn't my business. I just had to decode it. It was a challenge to write code that was down to the clock cycle, as efficient as possible. Doing the same thing for the NT form of compression, being able to get that as tight as possible. Being able to shape, the compression representation was part of that. But those pieces, this is sort of uber geek, but that level of work is what I enjoyed.
Yeah, you sort of alluded to it, but would you have your file system, NT file system, OSF, and Windows? Because these were sort of competing projects to yours. And I'm wondering what sort of your view of the competition was. Do you sort of do cooperation, or are they separate and the best person win? Or are they the enemies? Or, in other words, how do you deal sort of with this competition where there's probably one winner?
Competition between new technologies and existing technologies. My experience with dealing with IBM was interesting, because IBM would have 4 or 5 groups working on largely the same thing, and they would make some decision at the end that was probably very opaque about which technology was number one. IBM had, for example, was running at the time we were working on OS 2, they were running something called Top View, which was a character mode windowing thing. And they were about to go with that before we started selling them on graphical interfaces. Competing technologies in a company, even the size of Microsoft, if they're viewed as competitions, I think that there's the human aspect of that is horrible. People are people. They're going to view the competition almost in personal terms. The personal terms, when one project is given the go-ahead, that means the other one loses. The concept of losing is, something that we're just taught to avoid. It's hard to distance yourself, even after, for example, all the work that I did in OS 2 and in Cairo. You put a lot of effort into something, and to see it not go, that's a tremendous loss. Competing technologies, you need to structure them as cooperative. You need to work together. When one is intended to completely supplant the other, you need to actually probably share people between the two projects so that people understand that their expertise, their knowledge is not being just totally discarded.
If you were to speak broadly to the engineers at Microsoft, where now it's commonplace where you have development teams, as you were just saying, 1,000 here, 400 there, 500 there, taking dependencies among each other. If you were to speak broadly to all the engineers at Microsoft, what would you tell them in working efficiently, in working to make sure that we have the best product for our customers as possible?
Okay. Listen to your software architect. Oh, boy. I think that developers need to, there's a great quote from Dante, which is, "Heaven wheels above to you, showing to you her eternal splendor, and still your eyes are on the ground." Okay? Don't let your eyes be on the ground. Look around. See what everybody else is doing. You have to communicate. Communication is sort of the core of everything. Everybody has to communicate what they're working on. They have to communicate, not only just individuals working on a group, groups need to communicate with each other. Communication is not nearly as good as it should be here in terms of your day-to-day activity. Focus, individual developers focus. I think that one of the greatest increases in productivity that can happen in this country, in this company, is if they deleted Internet Explorer off your machine. Okay? Okay. It's all about focus. Figure out what you can achieve in a day. Don't flail if you find that you're running out of time. Just learn from that and plan on.
Hey, I'm Harry. You talked about, with the respect to the OFS, the big goal and some of the smaller steps towards getting there. Some of the other ideas around Cairo, around applications collaborating, what are some of the small steps that you think we could be taking towards getting towards a larger goal of having applications more richly communicating?
This spans into the programming model realm. We have something which is fairly good today, the COM programming model, but that's really very stateful in terms of the applications need to track what's going on in both sides when they're communicating. I think we need to think about a web service model, a stateless form of communication. It's going to be very difficult. It's a very big change in how programs are constructed. It's a big change. I don't know how to make that one a small one, outside of be able to provide a new programming model alongside the old, okay, and make sure that they interoperate as well as possible.
Hi, my name is Erin, and I have a two-part question. I know you've touched on this a lot today, but what do you think is your greatest accomplishment thus far? And when you leave Microsoft eventually, what do you want people to remember about you?
I've had so many things that I am proud of. It's hard for me to really say one stands out the most. The one that I derived as I mentioned before, the one I derived a lot of satisfaction out of was my individual contributor work for something small and fast. I think the work that I did in the installable file system realm and in file systems in general, I think is the thing I'm most proud of as a long-term thing that I've had here. Leaving Microsoft, MZ is okay, but that's not how I really define my contribution here. Hopefully there's more to me than my initials. There's a J in the middle. I think that I just look at the end result of the big products that I've worked on and how successful they have been. Even though the part of Windows 2000, my own direct piece of the file system part, yeah, that was cool, but I was part of a team that built something big. As much as I like the individual contributor stuff, I'm a team player. I like working in a team. I like having a bunch of people that we interact with. As much as programmers like to close their door and turn off the lights, we're social creatures. We need to have that. I think the camaraderie of building a product and shipping a product, okay, where everyone shares the vision, everyone works hard, the community that you form by that is the memory that I would take with me.
So I think that's it. I think we're ready to wrap up here. And I would like to thank all of you for coming with us to this look behind the code. And I would especially like to thank Mark Zbikowski for joining us here today. Thank you
pleasure.
very much, Mark. Thank you.